Hello, Algebra 2. Let's review Unit 5, understanding that graph and the meaning of f of x, which is just functions. First off, I just want you to know f of x does not mean f times x. Yes, it might look like multiplication, but it's not. Please don't think it is. This is actually going to be a function. So it's a function f of the variable x, or we just say f of x. Translation of the graph, otherwise known as transformations, otherwise known as OG shifty shifty. All the same. Same thing. All the same. Let's take a look. F of x equals g of x minus a plus b. That looks remarkably similar to something that we've been doing so often. Y equals x minus h squared plus k. This is the game of shifty shifty. The only difference here is you're basically just shifting it from the origin, which is actually what you've been doing this whole time. Alright, this is the shifty shifty of any shape. This is specifically dealing with parabolas. Let's just go with what we got for the first example. Given that the function y equals f of x shown to the right in blue, the graph a of x equals f of x plus 1 minus 3. The way I would remember that is you're shifting what was at the origin, what used to be at the origin. The new origin is going to be, think of shifty shifty. If this was to be an h and this was your k, you would have a negative 1, 3. Or negative 3, sorry. So what happened here is what was at this point is going to be shifted 1 to the left, going back 1, and then back down 3. That is your new point. Everything will match that logic. It's like chess. Alright, that's done. A lot more words, but the thing that I'm looking at is this right here. So it was shifted from here, we're going from here. If I was to jot that out as a shifty shifty or give a new coordinates of the shifty shifty, it would be 2, 2, 1. Because I have it as a negative, so it's opposite, which is positive, and this one stays the same on the outside the parentheses. So that is to the right 2, up 1. I choose a different color, and it's gonna go up. That was not pretty. And down. Next thing we're going to go up to do, well, I leave it to you. If your original function was x squared, what would be the shifty shifty of f of x minus 1 minus 3 plus 2? You do it. I'm going to say follow the logic, do the graph of f of x first, and then apply the logic of shifty shifty. Pause the video if you need to, otherwise, here we go. From the get-go, f of x equals x squared. That's just straight up a parabola. Standard go-to parabola. And since we're shifting it to a new point, that is going to be different color. It's going to be 3, 2. I'm going to move over 3, up 2 to this point, and that will be my new parabola. There you go. Alright, next thing that we want to cover is the operation of functions. The way operation of the functions work is you're treating them as elements in the domain of each function. So best ways to put it is, I read it best this way. The function f of x plus g of x could be also written as f plus g of x. f minus g of x can also be written as f of x minus g of x. F times g of x is f of x times g of x. F divided by g of x is also f of x divided by g of x. Note to here that in the division case, g of x cannot equal 0. Why? Because you cannot divide by 0. That's one of the rules that we're sticking to it. Best way I view functions and operations is treat it like a recipe. Bear with my analogy, just go with it. So if you had f of x, it was a recipe, and it tells me to mix a little bit of x with some flour and maybe some oil, poof, you get cupcakes. Yay, loving that cupcakes. Now, if you were f of g was to tell you to mix some sugar and some milk, you get poof, frosting. Meant to say frosting. Frosting, yeah. Anyways, I put it over here. So in this logic, if you had f plus g of x, that would be a recipe for cupcakes plus a recipe of frosting. You got frosted cupcakes. Yay! Or you can even have f of g of x. That's putting frosting inside the cupcake, because g of x is a frosting and f of x on the outside is the cupcake. So you just put the frosting into the cupcake. On the reverse, if you had g of f of x, that would be, I guess cupcakes in the frosting? Could be a thing. F of x is your cupcake, and you're now putting your cupcake into frosting. The logic, the analogy, it kind of crumbles to some degree, but you know what? I like it. We're going to use it for the time being. Plus, I found this beautiful picture of frosted rainbow ice cupcakes. Lovely. All right, let's just plug in some numbers and see where we go. F plus g of negative 2. That's the same as me saying f of negative 2 plus g of negative 2. All right, let's do them one by one. F of negative 2 equals, this is my set version, so negative 2 squared minus negative 2 plus 1. That's going to give me 4 minus, so that's plus 2 plus 1. That gives me 7. All right, that's not too bad. I'll do it in another color. My g of negative 2 equals negative 2 plus 2 equals 0. Nice. I'm just going to have 7 plus 0 equals 7. My answer is 7. G minus f of 5 is the same as me saying g of 5 minus f of 5. That is going to be plugging in a bunch of things. And g of 5 is going to be a little easier, so let's just do the g of 5 first, which is 5 minus, or 5 plus 2, which is 7. Switch my colors. F of 5 equals 5 squared minus 5 plus 1. Got 25 minus 5 plus 1. That is 21. And we're going to get a minus, so 7 minus 21 equals negative 14. Negative 14, not too bad. All right. F times g of negative 4 is the same as me saying f of negative 4 times g of negative 4. All right, plugging on things in. F of negative 4 equals, my original thing was x squared minus, take that back. negative 4 squared minus negative 4 plus 1. That gives me 16 plus negative negative is a plus. 4 plus 6 is 1. Gives me 21. Man, I'm getting got a lot of 7s and a lot of 21s, but bear with it. G of negative 4 equals negative 4 is it minus or plus? Plus 2. Plus 2, which gives me negative 2. This is multiply, so 21 times negative 2 equals negative 42. All right. F of G is same as f of 8 divided by G of 8. So let's plug in what we got. First one, f of 8 equals 8 squared minus 8 plus 1, that is 64, minus 8 plus 1, 56 plus 1, so 57. And my G of 8 equals 8 plus 2, which is 10. So 57 divided by 10 equals 5.7. Yeah, that kind of works out. Oh, there's still more. Ooh, f of G of 2. So now I'm just going to solve for G. Take that back. I'm going to solve for G of 2, which is 2 plus 2, which is 4. And then I plug that in to f of 4, because this thing becomes 4, and this thing goes into this. To explain that, this is 4 squared minus 4 plus 1. That is 16 minus 4 plus 1, 12, 13. 13 is my answer. And last but not least, we have G of f of x. So let's basically take everything f of x squared minus plus 1, that plus 2. I can simplify that to some degree. X squared minus x plus 3. Done. Not too exciting. Okay. Explaining what a relationship, a function, and a one-to-one function is with the Lion King. So, in the blue, let me explain what it is in a general sense. Maybe that will work a little bit. So, they're like Venn diagrams. This is the word relation applies to all of them. Everything is relationship. It's just how, if you have an X, it has some relationship to do with a Y. Don't know what exactly. It just, there's some bonding communication. One leads to the other. In a function, specifically a function, you have something that the X goes to exactly one Y. If I ever have an X and I ask, hey, where does this X go to? I know it exactly goes to a specific Y. In a function, X loves one person Y, and it's a functional relationship. A one-to-one function is when X only loves one person, Y, and that one person only loves X. They have X goes to Y, and Y goes to X, and they always go back and forth, and it works out perfectly. In a graph, something like this, that goes, anytime I have an X, I know it goes to a straight Y, and that Y goes to exactly that X. No confusions there. That's one-to-one. A function, there might be some confusion where Y has the potential of going to multiple X's, like your general parabola that we always work with. In a parabola, all of my X's can go clearly to a Y. But if I were to ask, hey, where did this Y come from? at this y height, what is my x value? I don't know, because it could either be this one or this one. This, though x might go to 1y, y doesn't necessarily only go to 1x. That's where it gets slightly tricky. And in a relationship, quite frankly, x can go to as many y's as it wants, and y's can go to many y's at once. It's complicated. That relationship is complicated. In terms of the Lion King, in the big sense, just imagine that Nala and Simba had a very open relationship. Nala had her friends, Simba had his friends. It's complicated. Things don't want to go into detail. If it were a function, then that situation would be, hey, Nala only loves Simba. Oh, that's sweet. Is Simba only loving Nala? I don't know, but I know that Nala only loves Simba, and that is just a function. As for a one-to-one, it is the situation where Nala loves only Simba, and Simba only loves Nala. Again, that means for every x, if I were to draw some type of situation, I like straight lines because any point on this line, it goes straight to one x point. This x point goes to this y point, and this y point goes to this x point. There's no confusion. That's one-to-one. You can check if something is a vertical line test, or check if something is a function or not a function by the vertical line test. So just try something out. If you had a general parabola, putting a vertical line around, going each time I only cross the line once, and thus it's an okay function. Had I had a different function, say this red function like this, that is a C+, if I pass my vertical line, does it pass the vertical line test? No, because I hit it right here, and I hit it right here, 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 right here. That does not pass the vertical line test. This is not a function. This is a relation, sure, but it's not a function. The blue one, if we go back to the blue one that we had initially, the blue parabola, go back. The blue parabola is a function, but it is not a one-to-one. Because if I said, hey y, at this height, what is your x? It could be this one, or it could be this one. I don't know. Y, you have two x's, that gets very dangerous. That does not function. Or no, that it's a function, but it's not a one-to-one function. Other things that you can check and note, other shapes that you're familiar with, circles and ellipses, they're not one-to-one, and they are not functions. They do not pass the vertical line test. Fail. As for range and domain, the domain is what x can be, and the range is what y can be. So if I were to ask you, because we've been working really well with our ellipses and circles, let's go something like that. So if I were to draw a circle, let's just draw a circle somewhere. I need the pen mode. So from here, just picking kind of random, but if I choose one right here, here, here. Okay. If this was my circle, for my domain, x can only go up to can only go to here and to here. So that's me saying that at 2, x is, or 2 is less than or equal to x, and x is less than or equal to 6. This is 6. For my range, I'm looking at what y can be, which 1 and 5. So 1 y equals 5. It can only go up to here, can't go here. By just looking at it, this circle only goes in this area, that loop. This applies a lot for some of our other graphs, like when we had exponential growth, it goes to the moon. I'm going to use a different color. It goes to the moon. But in doing so, it never goes across the negative side. I can have a bunch of, the domain goes far left and right, but the range only goes on the positive side. It depends on what the graph is. So domain begins with a D, associates with the X. R, range, associates with the Y. Alphabetical order, all alphabetical order. Inverse functions. The inverse function is the mirror of the functions over the y equals x line, the basic diagonal line. Here's that basic diagonal line. Right here. And all the points have matched accordingly. So had you had 0 or -2, 0, -1, 2, 1, 4, 5, 6, the matching inverse points would be 0, -1, 2, -1, 4, 1, 6, 5. If you notice, they had just swapped the x and the y location. Say if your function had the coordinates of -2, 4, -4, 7, -6, 10, the inverse function would have the same spots being at 4, -2, 7, -4, 6, 10, -6. The way you can think of it is they just swap them. Arrow goes this way, arrow goes that way. X and Y becomes Y and X. It's one of the few times that your Y actually goes before your X. In order to get this equation, however, you gotta do some work. To find the equation, the inverse equation, take the original equation, swap the X and the Y, and then solve it back for Y equals stuff. Let's check this out. If I have f of x equals 3x plus 6, let's rewrite this and swap out the x, the y and the x. So now I have x equals 3y plus 6. I'm going to move things around so that my y goes back to y equals. So minus the 6 minus the 6, divide by 3, divide by 3. This becomes 2 now. So I have y equals this. The inverse is going to be 1/3 x minus 2. Yes, yes, yes. Try this one yourself. You do. Pause. If not, here I go. Minus 6. Oh, undo. I want to change it so that it's now y equals square root of y minus 4 plus 6. I just swapped the x and the y places. And try to solve it so I get back to the y equals. So I'm getting minus 6, x minus 6. Then I have equals square root of y minus 4. I'm going to square everything, which then I get, this cancels out, so it's y equals 4. Over here I have x minus 6 squared plus 4 plus 4. And I have y equals 6 squared plus 4 equals y. Done. I can also, if I want to be fancy, I can write it as the inverse of x equals x minus y squared plus 4. Same thing. On your own, as a review, I highly recognize you understand what your inequalities are. I'll have very minimal questions about it, but hey, you should know how to read an inequality. This is less than or equal to, greater than or equal to, greater than, and less than. Alligator likes to eat the big thing. Chomp, 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 chomp. It looks like a monster. Alright, the rest I leave for you. If you would like to do as optional homework, I highly, highly recommend it. There's not much to do. You're just plugging things and practicing. Check your range and domain. I know a lot of students struggle with what range and domains are. this is an example of what I would probably test you on to know, can you identify what the range and domain is? I do highly recommend you doing these ones because this is a part of the review for Unit 6. See if you understand how to get the inverses. These are reverse operators. Are you good to do your Uno cards? You're gonna Uno reverse all of this. Reverse. All right. Good luck. Good go. Keep it up.